Hello everyone, welcome to Engineering Explained channel. In this session, I am going to take the basic thermodynamics model 3 lecture 2, that is thermal energy reservoirs. In that, I am going to take the thermal energy source, thermal energy sink, and heat capacity. Here, before going to take the explanation about the heat engine, heat pump, and the statements of the second law of thermodynamics, we have to know the thermal energy reservoirs, which are used for the explanation of the heat engine, heat pump, and the second law of the thermodynamics. Here we will take these thermal energy reservoirs. A thermal energy reservoir TER is a hypothetical body with a relatively large thermal energy capacity, that is called as the heat capacity also, which is a product of mass and specific heat. And that thermal energy reservoir can supply or absorb a finite amount of heat without undergoing any change in temperature. If the thermal energy reservoir supply or absorb finite amount of heat, it will not undergo any change in the temperature, that is called as a thermal energy reservoir. Example: large bodies of water such as oceans, lakes, or rivers, as well as atmospheric air. For this, any finite amount of heat if you supply or absorb from it, then these systems, oceans, lakes, rivers, as well as atmospheric air, does not undergo any change in the temperature. Those are called as a thermal energy reservoirs. Here we can see ocean, lake, river, atmosphere. Then in that source, a source is a reservoir that supplies energy in the form of heat. The reservoir which supplies the heat, uh, that is called as a source. Then sink, a reservoir that absorbs energy in the form of heat. Which reservoir absorbs the heat, that is called as a sink. And here we can see, okay, the source which will supplies the heat to the some system, and that again supplies the heat to the another reservoir, that is called as a sink. Then further details about this thermal energy reservoir we'll discuss. That thermal energy reservoir TER, a conceptual system that has an infinite or extremely large heat capacity. It can exchange large quantities of heat with a thermodynamic system without experiencing a noticeable change in its own temperature. It acts as an infinite pool. It acts an infinite pool of heat at a constant temperature. In that source, a heat source is a thermal energy reservoir at a higher temperature that supplies heat to a working system. The system draws heat from source to perform heat. Okay, here any system which will be draws the heat from the source to perform the work. Example: a furnace in a power plant that burns a fuel, or the sun's energy captured by solar collectors. Here, the furnace, what it is there, from which the heat is supplied to the boiler, and that is considered as the source. And the sun's energy, which will be captured in the solar collector, the sun will be considered as a source of heat. Okay. Next one, a sink. A heat sink is a thermal energy reservoir at a lower temperature that absorbs heat from the system after work has been done. This heat is then dissipated into the environment. Example: the atmosphere, a large body of water like ocean or river, or a condenser in a power plant, to which the heat will be rejected. After performing the work in the system by the heat, then the remaining heat that is considered as a wastage and that cannot be used for performing the work, that will be rejected to the atmosphere or a large body of water like a ocean, river, or a condenser in a power plant. How they work together, this source and sink together, how they work. In a heat engine or similar thermodynamic cycle, in heat engine or any similar thermodynamic system, heat is supplied from a source at a higher temperature to a working system. To the working system, heat is supplied from the source. The system performs work using some of this energy. The heat energy, what is there? Using some of that energy, the system performs work and then rejects the remaining heat to a sink at a lower temperature. Like this, the source and sink together work to perform the some work in the thermodynamic system. This can be, you can see from these sketches, thermal energy source which will supply the heat, thermal energy sink which will receive the heat, and which are used in the heat engines. The source which will supply the energy, part of that will be converted into work, and remaining waste heat will be rejected to a sink. This is a power cycle or a heat engine, we can say. And in the refrigeration and heat pump cycle, the heat will be received from the low temperature source and some work input is taken and that is rejected to a high temperature sink. And that the how the heat engine and heat pump works, those I am going to take in the further sessions. Thanks for watching. If you like, share, subscribe and comment.